Hi everybody and welcome back. In today's video, I just wanted to go over some updates and corrections from my last ladder test video. After getting some feedback and some comments from you, which I really do appreciate, I did some more research into the modern way of approaching a ladder test for developing a load. And there were a couple things that I was doing wrong, such as focusing too heavily on strictly velocity data from the rifle itself. Turns out that the new school way of doing things is to look at your groups, your group sizes, as well as using your extreme spread and standard deviation from your velocities that you measured to find what is going to work best in your rifle. So this is my updated ladder test 1.2. So just for this ladder test, I'm going to be working from 21.0 grain, increasing by 0.2 grain with 10 different variations, all the way up to 22.8. And I'm going to be doing strings of 5, as strings of 5 is kind of the minimum to get rid of the noise when measuring the rifle for velocity, consistency, and measuring extreme spread and the standard deviation of each shot. I set up a camera that was recording point of impacts, so I hope you enjoy this video of all of the hits. So when analyzing the results of this ladder test, initially had some potential decent groups for a first test, but overall it's not great. It was a pretty windy day. There was something else wrong with the rifle. As we can see here, I have all of the recorded velocities, and here's the average, the minimum and the maximum. The extreme spread, so the extreme spread being the difference between the minimum and the maximum, and the standard deviation of the set. So we're looking for a standard deviation of sub 20 and a low ES. The higher the number, the worse it is. As we can see, my two best sets are terrible for extreme spread and standard deviation. On the velocity data alone, my best would be group 4, which is this one here, but the string did not group very well, so I figured that there was something else wrong with the gun. I should not be getting velocity swings of 113 on a charge that has a consistent seating depth. After using a bore scope to look down my rifle, I realized that I had tons of carbon chunks built up in the neck area. I figured that this was most likely affecting my velocities like this, as well as the accuracy of the rifle. So I deep cleaned the rifle, got rid of all that carbon buildup right on the lands, and wanted to run this ladder test again to see if my results differ on the velocity front, as well as my group sizes. Here are the results of the revised ladder test. Set 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. As we can see, there's some promising stuff here. Here is the velocity data results. So, as we can see, after getting rid of all that carbon buildup on the lands, this is definitely better data here. So focusing on the standard deviation, we're looking for the lowest number. So that would be load 7, which is 22.2 grain. And funny enough, it also has the lowest extreme spread out of the string of 5. So limited data, basing solely off of the data plus the group size here. We can see that load 7 has some horizontal stringing, which is very promising. With the current clip, the maximum length I can get to is about 60 thou off the lands, which is not great for match bullets. Anyway, nonetheless, I'm going to run the seeding depth test next week with the 22.2 grain for 2 reasons. One being the horizontal stringing here, and number 2 being that it was my lowest extreme spread and standard deviation of the loads that I tested. So in combination with the velocity data as well as the group size, this is how I determined that I wanted to proceed with the 22.2 grain. So the following week, like I previously said, I'm going to run with the 22.2 grain, and if we look back here, bullet comparator measurement with the loaded rounds was 2.886, and I'm going to be starting at 2.89 with increments of 5 thou. I'm going to work all the way up to 2.935, which is 5 thou off the lands, always shooting the furthest off the lands, working my way up closest to the lands. What I'm expecting to see from this is, as I get closer to the lands, there's going to be a sweet spot, or I expect to see a sweet spot where the horizontal stringing tightens up. Also note that as I increase the seeding depth, velocities are going to change, as this will change the pressure of the charge and of the load. So I expect this value to increase the closer I get to the lands, as there's going to be more initial pressure. So stay tuned for next week's results.